Hey everybody, welcome to video notes 5.2. We're doing type 2 reactions this time. So you're going to be able to do all three of these things, hopefully, after these notes. So 11.2 of your book is the section that will help you the most, so please read it. Oh look, it's pointing to your book. So, get to know these 5 main types of chemical reactions. Synthesis, sometimes called combination, decomposition, single replacement, double replacement, and combustion of hydrocarbons. Those are the 5 types we're going to be working on. So, synthesis. Hey, look what happened here. 2 puzzle pieces came together to make 1. That's what's happening in a synthesis reaction. The simplest kind is when you have 2 elements. So this is generic, or general. Alright, so there's no element A or an element B. Okay, technically there's 4, but we're not talking about 4. Substance A and substance B are elements. The only thing those 2 elements can do is come together to make 1 compound. So here's an example. The element sodium and the element chlorine come together to make NaCl. The key to this is you have to cancel the charge to make the compound's formula correctly. Now this isn't balanced yet. If I put a 2 there and 2 there, it's a balanced synthesis reaction. H2 and O2 come together to make water. It's also not balanced yet. If I put a 2 there and a 2 there, it now is a balanced synthesis reaction. 2 things make 1 new one. Synthesis come together, combine. Okay, what's opposite of that? Decomposition. So in a decomposition reaction, you always start with 1 big reactant, and you're going to get smaller pieces as products. Those smaller pieces are almost always going to be elements for the ones that we look at. So if you wanted to write the generic equation for this, you could say AB turns into A plus B. And now you notice that it's the opposite of synthesis. So here's a compound, NH3, and notice you get the elements that it's made of. You may be wondering about these 2's. Well, remember our diatomic elements? Enough, cool, 3, 1, 2, 3, 4, 5, 6, 7 elements are diatomic, so when they're by themselves, you need a 2. Okay, carbon's not one of them, that's why it doesn't have a 2 next to it. Right. Here we'd have to go 2 and 3. Right. So far we've combined things to make 1, 2 elements to make 1. Here we've taken 1 compound and broken it into its elements. So here's some samples. We've got to decide what they are. Nitrogen dioxide decomposes. That must be a decomp reaction. Use those words to help you. Calcium reacts with oxygen. So this is an element. And this is an element. So it must be a synthesis or combination reaction. 1 reactant. So it'd be decomp. And 2 reactants, but they're both elements. It's going to be combination. Now, remember that synthesis and combination are the same thing. Okay? Right. The next kind of reaction is single replacement. So this is kind of a soap opera type of reaction because you're going to take an element and a compound, you're going to react them to produce a new new compound and a different element. It's kind of like you have a happy couple making a compound, right? And then an element that's like a home wrecker. So the element comes in, kicks out part of the compound. So you get a new compound and a different element. Okay. Now this reaction is you're going to need to look at something called an activity series to figure out what's happening. And then the element has to be active enough to kick part of the compound out. Oh look, a little soap opera drama there. Right. So an activity series is a list of elements from most reactive to least reactive. Notice all of these are metals, so it's called the metal activity series. Those are non-metals. So metals can only replace metals. Metals only replace metals. Only replace metals. And then non-metals can only replace non-metals. Non-metals only replace non-metals. Okay, a metal can't replace a non-metal. It can only replace what they're similar to. So we're looking at this going, okay, this is a single replacement. Here's a K. It's a metal. So you have to see if it's higher up than this part. So here's K. Here's Na. So this reaction will work. And you'll get KCl plus sodium gets kicked out. Why? Potassium is more active than sodium, so it works. Okay, here's the element tin right here on the activity series. Since tin's a metal, you have to look to see if it's higher than aluminum. Aluminum is higher, so this is going to be no reaction. So how do you know this is a single replacement? Well, you have an element plus a compound. Right? Oh, look, it's an element. and a compound. So it's going to be a single replacement reaction. Then you look to see if the element, Br, is higher than what? Well, Br is a nonmetal. So to see if it's higher up than the non-metal part. So Br is here, and it's higher than iodine. So Br will go in and kick out iodine. That means lithium is going to hook up with the Br, and iodine gets kicked out. This is +1, -1. That's why it's LiBr. This is diatomic. That's why it's I2. Okay. Element, compound. See if the element's higher than what it's trying to kick out. Well, Cl is a nonmetal, so it's trying to kick out F. And no reaction because, because chlorine does not have the ability to kick out chlorine. Okay, these are called single replacement because it's an element plus a compound. All right, hey, if there can be a single replacement, there can be double replacement. This is a little less dramatic because everybody ends up with another substance. In a double replacement, the elements change partners, but everybody still has a partner. Keep this in mind, that in a compound, whatever's in the front of a compound always has to be in the front of a compound. So if you look at it and you have compound AB and compound CD. A is in front, so A has to be in front. So what's the difference? B and D switcheroo. Okay. So you're starting with a compound and a compound, and you get two new compounds. But notice, whatever was in front on the reactant side has to be in front on the product side. Here's some things to remember, that the reactants are always going to be aqueous. So that's a clue to know. If you have two aqueous compounds as reactants, then you're going to get products for a double replacement. If one of the products is a solid, that's what we call a precipitate, or it's water, or it's a gas. So double replacement, two compounds, do the switcheroo. Okay. So here's some samples. All right. It says sodium chloride, that's a compound, reacts with lead, another compound. The type of reaction for that is double replacement because it's a compound plus a compound. Here we have a compound plus a compound. Okay, and you get two new compounds, so this is double replacement. Here you have a compound plus a compound, and so it must be double replacement. Potassium iodide is a compound, reacts with aluminum nitrate. It's a compound. So since these are compounds reacting with compounds, it's double replacement. Okay. So what's going to switch places? Well, potassium's in front, aluminum's in front. So that means the nitrate and the iodide have to switch places. Copper's in front and barium's in front. So that means fluoride and sulfate are going to switch places. And we'll practice those in class. Okay. Hey, what's a precipitate? A precipitate is a solid that comes from two things mixing. All right. So remember when I mixed the two clear liquids together and got that yellow stuff? That's a precipitate. So the state of matter you put next to precipitate is S for solid. Aqueous is dissolved, so it's not a precipitate. S is a solid, so it's not dissolved. That's called insoluble. Oh yeah. So combustion is the fifth type of reaction. In order for things to combust, we're going to look at burning hydrocarbons. So we're looking for compounds with C's, H's, and sometimes O's. Okay. Those are the elements that are in most hydrocarbons. Oxygen also has to be present. And then the products are always going to be carbon dioxide and water. Hey, is that a lab report? I hope not. So, some samples. Here is a hydrocarbon. But how do I know this is going to be a combustion? Because it says it burns. So really, it's CH4 plus O2. And you'll be able to tell me, hopefully very soon, that you'll always get CO2 and H2O. But notice, this is combustion because even though it's a compound and an element, if the element is oxygen and the compound has C's and H's in it, then it's going to be combustion. Okay. Look, it's CH4 plus O2. I don't even need to look at the products because I already know that this is a compound and an element, but the element is oxygen and the compound has C's and H's. So this is a combustion reaction. Combustion. Sugar burns. Well, this has carbon and hydrogen. What makes it burn? Oxygen gas. So this is combustion. So there's 5 types of reactions. We talked about them all. So let's try to identify them. Here they are listed again, and here's some hints to help. And you aren't going to get the hints later on, but for now we're still learning. So I'm looking at this. I'm going, okay, this is an element, and this is an element. So what do two elements do? They combine. So this is synthesis. This is a compound and a compound. Compound and a compound is a double replacement. Okay. Here's a compound and an element. But wait, The element is oxygen and the compound is C's and H's, so this is combustion. This is double replacement. Okay. So you're looking at this going, that's one big thing. Sure is, it's a compound. So if there's only one reactant, and that reactant has to be a compound, it's going to decompose. Okay. Finally, we have an element plus a compound. Now, if the element is not oxygen, then your element compound is going to give you a single replacement. Alright, so we looked at one of each replacement. And so, just to review, here's the general equations that you can use to describe the 5 types of reactions. Alright. Now, these 4 can be recognized by, it could be pretty much any substances. But combustion is specific. It has to be O2 and a hydrocarbon. Okay. So please read section 11.2 and check out these interesting objectives.